Okay, so you got a basic idea of how to find the derivative of inverse trig functions. We're going to look at a slightly more complicated example, and that's just because when we do our chain rule, we have a fraction inside of our trig inverse. So things are going to get a little uglier algebraically. This is my second attempt at making a video, so if you think this looks scary, please follow along because I already did it once and then I figured out an easier way to do it. So I'm going to try to show you the easiest way to handle this algebraically speaking. Okay, the trig is going to be the same as what you've been practicing. So let's go ahead and write out our chain rule. If you don't like to write it out the long way, you can follow along and sort of do it your way. But I know a lot of you are used to doing it this way. So cosine inverse of, let's make that a u. Okay, so I've got y equals cosine inverse of u, and then my u is 1 over x. And let's just find the derivative of both of those. So my y prime, here's where I apply my new rule. 1 over, oops, it's got a negative in front, negative 1 over radical 1 minus u squared. Since it's a cosine, we've got that follows from my sine. So using the new rules. U prime, I'm going to rewrite this as x to the negative first, and I'm going to handle that as a power rule, negative 1 x to the negative second, which is negative 1 over x squared. And now I'm going to put those together. So my chain rule tells me that dy dx is going to be dy du, or y prime, times du dx, or u prime. So that's going to be a negative 1 over radical 1 minus, let's go ahead and put my u in. So my u is 1 over x. And that's going in for u here. And then times negative 1 over x squared. So I'm going to deal with this denominator, and then I'm going to go ahead and see what I end up with. I know that I can write 1 over x quantity squared as 1 squared over x squared. And 1 squared is obviously just 1. So I'm going to look at this as a fraction minus a fraction. 1 is the same as 1 over 1. And I'd like to get common denominators there. So let's multiply by x squared. Whoops. Over x squared in this fraction, and that's going to allow me to subtract. Subtracting fractions, so I'm just working with the inside here. Subtracting fractions, I keep the denominator the same, so I'm going to get x squared minus 1 in the numerator, and x squared in the denominator. That's my common denominator. So that's all inside of my square root, and then we do have a property of square roots that the quotient of two terms or two parts inside of my radical is the same as the quotient of two radicals. So square root of x squared minus 1 over square root of x squared is an acceptable rewrite of that. So putting all that together, I end up with a negative 1 times a negative 1 in the numerator is going to give me just a positive 1 over, I've got this x squared that I'm going to put out front, and then my entire radical here I have now rewritten as square root of x squared minus 1 over square root of x squared. Okay, so I do have a complex fraction, but let's see if I can simplify my denominator, then I might actually not have to multiply by the reciprocal. If I do, I will. So I'm interested in this the x squared that I have here and the radical x squared. Radical x squared is basically the same thing as x, right? So it appears that I could simplify that, and I could cancel this with one of those x's. And I basically can. I'm going to add one note to that, but let's go ahead and write what we've got. And that note has to do with my signs. So I'm just going to take a quick second and think about this. If I have x squared, that's going to make something positive. If x is positive, it's positive. If x is negative, it's going to end up being positive. Now, if I have square root of x squared, that's also going to be positive because I would square something and then take the square root of it. So this altogether, this fraction, x squared over radical x squared, is going to end up positive. So problem is, if x is negative, now I'm going to have a negative because my x squared over square root of x squared ended up simplifying to just x. So to deal with that sign issue, all I'm going to do is I'm going to put absolute value bars around x, and then it's going to be exactly equivalent to what I had over here, and obviously a lot simpler. So that's going to be my final answer. Okay, so the absolute value of x was not in the formula. That was because of me thinking about signs. Interesting if you look at your answer, because that actually is a different rule. So I'm going to let you ponder that if you're interested. Let's try another one. So let's go ahead and do y equals sine inverse of 3 over x squared. So another one with a fraction. We could be doing tangent inverse also here. I'm dealing with sine and cosine because they're a little bit more complicated with the radicals. So I think tangent you'll find a little bit easier. So I'm going to take the same approach this time. Feel free to try it on your own and sort of compare as we go. Sine inverse of u, and my u is 3 over x squared, which I'm going to rewrite as 3x to the negative second. Okay, so I've got y prime is 1 over radical 1 minus u squared, no negative this time, and my u prime is a negative 6x to the negative third, which is negative 6 over x to the positive third. So let's put that together. dy dx equals 1 over radical 1 minus, and I've got something squared, and that something is my 3 over x squared, putting that in for u. Make sure you don't miss that squared part. X is being squared inside of your squared. And then I've got to multiply that times a negative 6 over x cubed. So again, I'm going to go ahead and deal with the denominator part, that's just multiplication, denominator part, and I'm going to end up with a 1 minus 3 squared is 9 over x squared, squared is x to the fourth. And I want to get a fraction, one simple fraction in there so I can separate the numerator and denominator into two radicals. So I'm going to multiply by x to the fourth over x to the fourth, and that's going to give me radical x to the fourth minus 9 all over x to the fourth, combining because I have one denominator, and then I can actually write that as radical x to the fourth minus 9 over radical x to the fourth. So that gives me a, what do I have here, negative 6 in the numerator. Denominator is x cubed times what I had here in blue is now radical, this is what I'm separating into radical x to the fourth minus 9 all over radical x to the fourth. And let's look at what we, sorry about that. Let's look at what we have here. So I want to try to simplify this. And I have a complex fraction right here. Can I go ahead and simplify these? So square root of x to the fourth is basically just x squared. So I'm going to cancel that with two of my 3 x's that I have, which is going to give me negative 6 over x, radical x to the fourth, minus 9. And if you're thinking about the last example that we just did, you should be asking yourself, well, wait a second, do I need absolute value bars here? So let's think it through, because that's just going to be a matter of my signs. So I had x cubed right here. X cubed, if x is a negative, is really what I'm concerned with. That's going to be a negative. Square root of x to the fourth is going to be a positive. So I'm going to have a negative divided by a positive, which is a negative here. So if my x is a negative, then this is going to be negative, and that's exactly what I want. I do not need to make it positive this time, and therefore that is my final answer. Okay? Hopefully that makes sense. Let's try one more that has a little bit different feel to it. Okay, so another sine inverse, and this one I'm going to do basically the same way. When we look at our u, what we've been doing is making that inside my u, but I'm actually going to do something different here because 2x is too complicated to keep inside of my radical. So I'm going to make it u equals radical w, and then I'm going to have a w here is equal to 2x. So my double chain, because we know how to handle that, right? So y prime is 5 times 1 over radical 1 minus u squared. Is is what I have first, and then I'm going to have u prime. So I'm thinking of that as w to the 1/2. A lot of you have memorized that that ends up 1 over 2 radical w. If you need to write it out for yourself. And then w prime, is 2. So I'm really just taking all of those and multiplying them together because that's what my chain rule allows me to do. So I did tell you the chain rule is never going away, right? Okay, cool. So I've got 5 over radical 1 minus, let's just go ahead and put our u in. So I've got something squared, and I'm grabbing that from here. U is radical w, and w is 2x. So radical 2x, all being squared, times 1 over 2 radical w, and again w is 2x, and then times my w prime, which is 2. That's just multiplication. So I'm multiplying these three derivatives, and I'm noticing that I have a 2 and a 2, and that's in the numerator, that's in the denominator, so those cancel. And I think we're actually pretty much ready to just throw this all together and call it our answer. I've got 5 in the numerator, it's the only thing I have in the numerator, and then my denominator, I've got a radical 2x, that's coming from over here, and then I've got this radical, 1 minus, and 2x, radical 2x squared, the radical and the square cancel each other out, and I've just got a 1 minus 2x inside of my radical. And that's done, folks. We don't have to do anything else to it. So that one ends up being a little bit nicer because I don't have the fraction inside of it. There's one more. I'm going to have you try that one on your own. It's similar to the first two we did. Doesn't have the variable in the denominator, but it does still have a fraction. So give that a try and see how it goes.